Okay, this will be our last copy demo, and in this one what we're going to populate is the dim date table. Now the dim date is where we're going to store all those dimensions where we want to slice things out by either a date or a day of the week or a month of the year or a quarter, and all those calculations that you'll get specifically with sales so that you could compare the number of sales on the first day of the month to the last day of the month, or the first week of the year to the last week of the year. Now all the records for the date dimension table are actually stored in this JSON formatted file. Let me bring that up here and you can see that each record is represented by just a block of JSON. It's all stored in one big well-formed JSON block. And by now you should be really used to the copy command, copy dim date from that same Redshift load queue bucket, the same region, and that Redshift S3 role that we have been using. Now keep in mind that there are other ways to authenticate, but using this role is not only the easiest, but is the recommended best practice. Now for this file, we're going to list it as a format JSON, and then we have two options, the first being simply auto. What we're telling Redshift is, hey, figure it out. It should be well-formed JSON data, so it should be pretty self-explanatory. The other thing we can do is put a reference to a JSON path statement here, which gives a better definition to that JSON file. Because maybe some of your attributes don't line perfectly up with some of the fields you have, and you need to give Redshift a little bit more information to figure out what data goes where. But for this one, all of our attributes line up name to name, so we're just going to go ahead and leave it auto. And by that, I mean that we have an attribute named date key, one that's named alternate date key, one that's named day of the week. They all line up, and something to store away in long-term memory. It is case sensitive when you do a JSON file like this. All right, so we hit run. And right away we get back an error. Speaking of loading things into your long-term memory, this Redshift system table, STL load errors, is likely something you're going to be referencing quite a bit when you start loading data into your Redshift clusters. Just building these demos, I've had to reference it several times to figure out what I had done wrong in just building my own sample files. So let's take a look inside this table and see exactly what error occurred so we can figure out what we need to do to troubleshoot and then fix it. If I do a quick select star from that STL load errors table, you can see that we get information not only on the exact time and user ID for each error, but it also references the node slice that it was working on. Now to make this a little easier to see which error was ours, I'm going to order this by start time and rerun the query. And here at the end, we see that our specific error is invalid JSON path format. Member is not an object. Now, it's not terribly self-explanatory. I told you that we had a well-formatted JSON document, so we didn't really need to specify a JSON path. But this error seems to be telling us that it couldn't figure out our JSON document from just the auto setting. Well, there's kind of an interesting nuance when loading JSON data from a text file with Redshift. It doesn't actually want a well-formed JSON document. What it wants is a listing of individual JSON documents in a one-to-one relationship between each document and the record that it's going to be inserting. So to get this to work, what we have to do is remove the opening and closing brackets. In doing that, we identify that this is no longer one big JSON block, but a whole bunch of individual items. Now we could run this again, but we would get another error and it would say that it doesn't know what to do with the comma that's in between each of the attributes. So we're going to have to do a quick find and replace and get rid of all these commas. But that's fairly easy to do. We'll just highlight it here, go to replace, and enter a closing bracket without that comma separation. All right, so what you see here is actually what it's looking for. A listing of individual JSON items that line up each individually to one record. So for example, this chunk I have highlighted here would be one row. This chunk here would be another row. By listing that entire thing as one JSON document before, it thought that I was intending to stick all of that data into one single record. All right, so we'll save our new file and then go ahead and upload it to our load queue bucket. We'll try that command again. And in just a handful of seconds, we entered some almost 2,200 records. Now there's a couple of different formats that it can use under that default auto setting. I'll go ahead and go to the AWS documentation page to show you. You can list it like we did, here this top example, or you can list them as individual arrays. Now, neither of these are really well-formed JSON, but they take that concept of an attribute element and a value statement enclosed in documentation that's very similar. Now, if you had actual legitimate JSON data that you wanted to load in this, say from a database like DynamoDB that is storing actual JSON documents, you wouldn't really do that from an S3 storage bucket. The way you would identify that is you'd get rid of this JSON statement and then replace this S3 bucket with a declaration to a DynamoDB database. If you were going to use DynamoDB, you would also need to use an IAM role that authorizes access to that DynamoDB database. Now, DynamoDB is a little bit outside the scope of this course, so I'll let you research more of that on your own. Now, what are some of the other formats that you could load with this? Well, you could do Avro files, pretty similar to these JSON files that we just loaded, only they're stored in a binary format. You can do all sorts of delimiters. There's several zip technologies that are supported. And if you wanted to load data from an external source, you could do that through an SSH session. So your from clause would actually specify an SSH source. All right, so next we're going to talk about working Redshift into your ETL processes. How do you handle staging and how do you handle transformations and what are some of the best practices for doing that?